लास्ट लेक्चर में हमने पढ़ा था वैलेंस बॉन्ड थ्योरी के बारे में। आज हम करेंगे हाइब्रिडाइजेशन, a very important topic of this chapter. So actually hybridization is here to remove the limitations of VBT. As in VBT we studied that while forming the bond between nitrogen and hydrogen, just I show you where is the limitation. So nitrogen की configuration थी 1s2, 2s2, 2p3. So this is its valence shell. It's 2s and it's 2p. Okay. हाइड्रोजन का था 1s1, इसका भी 1s1, इसका भी 1s1. So you can put here 1s. Okay, right. This you can put second 1s here. Third one is here. It has 2 and 3. So we just made the bonding in the half field. हमने यहाँ पे ऐसे bonding show कर दी थी कि ये इसके साथ bond बनाएगा, ये इसके साथ, ये इसके साथ. Now where is the problem? Problem is that this suppose this p orbital is 2px. This p orbital is 2py and this p orbital is 2pz. तो कोवलेंट बॉन्ड की टाइप्स में हमने ये पढ़ा है that 2pz and s they can overlap. S orbital and 2py they cannot overlap. S orbital and 2px they also cannot overlap. So this overlapping is wrong in VBT. So to explain this, there is a new term that is a hybridization. In hybridization, the basic concept behind hybridization is that before bonding with these hydrogen, the atomic orbital, these are the atomic orbital 2s, 2px, 2py, 2pz. Atomic orbitals of the central atom they intermix before forming bond with these attached atom. The atomic orbitals of central atom they intermix to give new set of orbitals, that is called hybridized. Hybridized means mix up, having different characters. So before forming bond with hydrogen, the atomic orbital of nitrogen they mix up to give a new type of orbitals known as hybridized orbitals, and these hybridized orbitals they have a tendency to overlap with any orbital. So in this way the limitation of this VBT is removed. So let's see the definition of hybridization. So hybridization is a intermixing of atomic orbitals of an atom having different energy and shape to redistribute their energy to give new set of orbitals called hybridized orbitals. इसको HO बोल देंगे. And this phenomena is known as hybridization. This is the definition of hybridization. So now we will understand the hybridization, then we will take the examples, types. So there is intermixing of atomic orbitals of an atom. एक ही एटम के atomic orbital, जैसे नाइट्रोजन के atomic orbital थे 2s, 2px, 2py, 2pz. तो ये टोटल 4 atomic orbital हो गए, है ना. Having different shape and energy. एनर्जी डिफरेंट है, 2s की एनर्जी कम है, 2p की एनर्जी ज्यादा है. Different energy and different shape also. S orbital spherically symmetrical है, p orbital dumbbell shape है, पढ़ा हमने. तो atomic orbital नाइट्रोजन के having different energy and different shape, they redistribute. When they mix up, they redistribute their energy to give a new set of orbitals called hybridized orbital. तो 4 atomic orbital थे नाइट्रोजन में, एक 2s था, 2px, 2py, 2pz. चारों मिक्स हो गए. मिक्स होने के बाद उन्होंने अपनी एनर्जी को रीडिस्ट्रीब्यूट किया, सबको इक्वल एनर्जी मिल गई, सबकी शेप इक्वल, सबकी एनर्जी इक्वल. जो हाइब्रिडाइज्ड ऑर्बिटल बनेंगे उनकी एनर्जी भी इक्वल होगी, उनकी शेप भी इक्वल होगी, सेम होगी, एंड सेम नंबर भी होगा. जैसे 4 एटॉमिक ऑर्बिटल मिक्स हुए थे तो 4 ही हाइब्रिडाइज्ड ऑर्बिटल बनेंगे. फिर वो हाइब्रिडाइज्ड ऑर्बिटल जो बने हैं वो अटैच्ड एटम, जैसे नाइट्रोजन के साथ 3 हाइड्रोजन थे, उनके साथ बॉन्ड बनाएंगे. तो ये है कॉन्सेप्ट ऑफ हाइब्रिडाइजेशन. इसमें क्या है कि हाइब्रिडाइज्ड ऑर्बिटल की टेंडेंसी होती है बिकॉज दे हैव द सेम एनर्जी एंड सेम शेप, सो दे कैन ओवरलैप विद एनी ऑफ द ऑर्बिटल, वेदर इज देयर एस और px और py और pz, एनी ऑर्बिटल. Even sp2 hybridized orbital they can also overlap. sp3 hybridized orbital they can also overlap. तो जो एटॉमिक ऑर्बिटल्स थे उनके नाम थे 2s, 2px, 2py, 2pz. जो नए ऑर्बिटल्स बनेंगे चारों को मिक्स करने के बाद उनके सबके नाम सेम होंगे. 4 हाइब्रिडाइज्ड ऑर्बिटल बनेंगे. फर्स्ट का नाम sp3, दूसरे का नाम sp3, तीसरे का नाम sp3, चौथे का नाम sp3. sp3 क्यों? क्योंकि वो एक s और 3 p के मिक्सचर से बने हैं, है ना. सबका नाम sp3, 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 sp3 हाइब्रिडाइज्ड ऑर्बिटल होगा. ठीक है, तो देखते हैं इसकी एग्जांपल्स. इसकी कुछ टाइप्स हैं, 6 टाइप्स हैं टोटल. पहले हम 3 करेंगे फर्स्ट अच्छे से. टाइप्स ऑफ हाइब्रिडाइजेशन. फर्स्ट है sp, sp2, sp3. सीधी सी बात है. sp का मतलब उसमें एक s ऑर्बिटल, एक p ऑर्बिटल. इसका मतलब इसमें एक s, 2 p. इसका मतलब एक में एक s और 3, इतने ऑर्बिटल पार्टिसिपेट करेंगे. तो देखते हैं सबसे पहले sp3 के बारे में. sp3 हाइब्रिडाइजेशन में क्या होता है? देयर इज 1s ऑर्बिटल combined with 3p orbital. Intermix. Like this is your s orbital and these are the 3p orbital. pz, px, py, you can write it. This is s, this is p, this is p, this is p. Okay, these are the 4 atomic orbitals. They mix up. Give a 4 hybridized orbital. है ना? तो ये कितने बनेंगे? अगर ये 4 है तो ये कितने बन जाएंगे? 4. What will be the shape or the symmetry of these hybridized orbitals in space? That will be given by the Sepper model. Means if we have a 4 electron pair, according to Sepper model, what is the geometry? That is the tetrahedral. So these 4 hybridized orbitals, they are also present in the space in a tetrahedral form like this. So to distinguish this lobe and this lobe, you put a small lobe inside it. which represent the, it is mix up, hybridized. So this is sp3 hybridized, this is sp3 hybridized, this is sp3, this is sp3. So these four hybridized orbitals are formed. These are atomic orbitals having different energy, different shape, but when they mix up, they give us same identical sp3, 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 sp3 hybridized orbital. After that, they form the bond with the attached atom. Now let's see Sapper model. If we take an example of ethane, let's see, carbon is 1s2, 2s2, 2p2, carbon in ground state. ग्राउंड स्टेट में क्या होगा, 2s में 2n और 2p में भी 2n. कार्बन इन एक्साइटेड स्टेट, तो 2s में से एक इलेक्ट्रॉन जो है वो जंप करके 2p में चला गया. दिस इज 2p, दिस इज 2. सो बिफोर फॉर्मिंग बॉन्ड विद हाइड्रोजन, these four orbitals, one s is there and 3p. So these four these atomic orbitals, they mix up to give this, and when it gives this, so you can write it carbon. So these are the hybridized orbitals. So you know the hybridization of carbon is sp3 in methane. हाइब्रिडाइजेशन कैसे निकालने के लिए बताऊंगा. ये हो गया इसका. अब जो हाइड्रोजन है, they can form a bond here. One hydrogen, another hydrogen, third, fourth. So this overlapping, you can see here, this overlapping is called sp3s overlapping. There are four such overlapping here. So structure is same as that of the Sapper model. Tetrahedral, okay, bond angle 109 to 8 minutes. So this is all. There is a combination. You can see the three concepts. Hybridization, the Sapper model also involved, and this is VBT that get also involved here. This is called hybridization. Okay, so this is about the sp3. Now, like sp2. Hybridization. In sp2 hybridization, we can see that there is one s and 2p orbital. They will participate. Okay, sp2, 1s plus 2p. This is s. These 2p. So total there are 3 atomic orbitals. They mix up, obviously they give 3 hybridized orbitals. What will be the shape for 3 according to Sapper model? It is trigonal, planar. Same will be here. 1, bond angle 120. This is sp2, this is sp2, this is sp2. Now see the example, boron. Boron has configuration 1s2, 2s2, 2p1. So first we will write boron in ground state, 2s2 and 2p1. Then we will write boron excited state, 1 electron from S that jump to P. Now we have these 3 orbitals. You can see these 3 orbitals. One is S and 2p. They intermix to be this 1p orbital. This do not take part in hybridization. This is called empty p orbital, or it is unhybridized, will not take part in hybridization. So this is your boron, 1 bond, 2 bond, 3 bond. This is sp2, this is sp2, this is sp2. Put hydrogen here, hydrogen here. These three are in one plate. Now where the P will be present? P will be present perpendicular to this. That's empty. This is your P orbital, unhybridized. We can draw the structure as B, H, H, H. Trigonal planar with a bond angle 120 degree. So this is called sp2 hybridization. Okay. So in hybridization, you must take care the number of atomic orbitals will be equal to number of hybridized orbitals. Next is sp. Let's talk about sp. One thing here is that if we have this BF3, we have BF3 instead of BH3, then what will be the structure? Then we have a boron with a 3 hybridized orbital, sp2, sp2, sp2. Now फ्लोरीन का कौन सा ऑर्बिटल है जो वो ओवरलैप करेगा? फ्लोरीन की कॉन्फ़िगरेशन होती है 2s2 2p5, दिस p1. तो इसकी फिर स्ट्रक्चर आप ऐसे बनाओगे, है ना? p ऑर्बिटल ओवरलैप करेगा. And now this overlapping is called sp2p. Okay, this overlapping is sp2s. You can see here. Come to sp hybridization. In sp hybridization, as the name indicates, one s and one p orbital get involved. One s, one p. Like this is s, this is p. Only two. So there are two atomic orbitals mix up. Give two hybridized orbitals. What the Chapter model say about two? It says linear geometry. So it will be like this. This is sp, this is sp. BEH2 example, BE 1s2 2s2 2p0. अगर आप ग्राउंड स्टेट में लिखोगे तो 2s में 2 आ जाएंगे, लेकिन 2p में क्या रहेगा? 0, है ना, खाली. तो अगर आप बेरिलियम को एक्साइटेड स्टेट में लिखोगे तो 1 electron from 2s that jump to 2p. So this is 2s, this is 2p. Then you can see 2 electrons are there. So 1s and 1p, they intermix. What are these? These are two unhybridized p orbital. Empty. Okay. So beryllium is at the center. One sp hybridized, second sp hybridized. This is like this. And here you put hydrogen. Here you put hydrogen. So this overlapping is now of sps. Two p orbitals are perpendicular. One is like this, second is like this. Okay. जो p अनहाइब्रिडाइज्ड ऑर्बिटल है वो इसके पास ऐसे पड़ेगा. These are unhybridized orbitals. So the geometry will be BE H H 180 linear. This is a basic concept of hybridization. These are most commonly used hybridization in various other concepts also, sp, sp2 and sp3. नेक्स्ट है हमारे पास 3 और हाइब्रिडाइजेशन. इसमें डी भी इन्वॉल्व होगा. sp3d, sp3d2, sp3d3. Next is sp3d hybridization. In this hybridization we have one s orbital and 3p orbital and one we have a d orbital. So d orbital used in this case is dz square. This is your pz, this is px, this is py. So now we have these 5 atomic orbitals. So just keep in mind that in this type of hybridization like sp3d, the d orbital which is used is dz square. You must memorize this. Which d orbital is used in sp3d hybridization पूछा जाएगा. तो कौन सा d orbital use होता है? That is dz square. Now these 5 hybridized atomic orbitals, they mix up to produce 5 hybridized orbitals. And according to the Sapper model, what is the geometry for 5? It is trigonal, bipyramidal. So you should just draw the hybridized orbital according to that geometry. We have 1, 2, 3 in one plane. Okay, no, this is in one plane, and one is above the plane, one is below the plane. So all are sp3d hybridized orbital. You can see here, all have a same shape, all have a same energy. If we talk about the VBT, so when you take the example of PCl5, phosphorus, atomic number 15, configuration 1s2, 2s2, 2p6, 3s2, 3p5, 10, 3, 15. So phosphorus in ground state, you can write just these orbitals. We have 3s, we have 3p, we have 3d, but here it will be empty, like 3s, 3p, 3d, 2 in this, 3 in this. So when you write the excited state of phosphorus, so one electron shift from 3s to d. Okay, so 1, this become a, now you can see there are 5 unpaired electrons, and these 5 unpaired electrons, these orbitals, just compare these orbitals, these 1s, 1, 2, 3p and 1d. So they intermix to give rise this type of hybridized orbital. So at the center we get a p. Around it we get a hybridized orbital like this, sp3d, 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 and here we get a p long side because we are going to add a fluorine all side, chlorine or fluorine all side. These are the chlorine. First structure become P, Cl, Cl, triangle, and 1 Cl below, 1 Cl above. So this is about the sp3d hybridization. So you must memorize only one thing here, that which d orbital is used. So that is 3dz square orbital. Next is a sp3d2. Now we will use 2d orbital. Okay. So these are the starting from sp to sp. This is just parallel to that receptor model. That electron pairs are 2, then 3, then 4, then 5, up to 7. Here we are also going in the same way. Then sp3d2. So here 1s, 3p, and now 2d. Which 2d again you have to memorize. Okay. This is S, PZ, PX, PY, dx square, y square and dz square. These two d orbitals, they mix up. Now we have a total 6, and when you draw the hybridized, there will be 6 hybridized orbital, and according to Sepper model, what will be the geometry? Octahedral. So shape of the molecule is depend upon that will give information by the Sepper model. Okay. Now draw the octahedral. 1, 2, 3, 4 in square planar form. Okay, like this. 1 is above, second is below. So like this. So all these hybridized orbitals are called sp3d2, sp3d2, sp3d2. So you can see here 6 hybridized orbital having same energy, same shape. Example is SF6. This 6 that you can calculate by using the same method as that of Sepper model. Sulfur has a valence electron 6, 6 monovalent divided by 2, 6 same. So 6 means its hybridization is sp3d2. This 6 means it's sp3d2. If there is a 5, it means that's sp3d. So if there is 4, means sp3 only. So sulfur has 1s2, 2s2, 2p6, 3s2, 3p4. So this is the ground state. You can draw 3s, 3p and 3d. 3s, 3p, 3d. In s we have a 2, in p we have a 4. In excited state, what happens? These electrons, they shift to provide 6 unpaired electrons. You can see here 1, 2, 3, 4, 5 and 6. So these 6 hybridized orbitals, these 6 atomic orbitals are these. Like you can say 1 is S, 1, 2, 3 P and 1, 2, 2D. So they get the same quantity, same like if you put here sulfur. Okay, and the fluorines are attached like this. Fluorine, 1, 2 fluorine, 3, 4, 5 and 6. The geometry you can draw easily. SF6 is a octahedral geometry. All the bond angles are 90 degrees. So this is sp3d2 hybridization. Then the last hybridization, as I told you that जैसे जैसे हम सेपर मॉडल में जाते हैं 2 से लेके 7 तक, ऐसे ही इसमें है 2 से लेके 7 तक. जब 2 होता है इलेक्ट्रॉन पेयर तो लीनियर ज्योमेट्री, और अभी उसी की लीनियर ज्योमेट्री की हाइब्रिडाइजेशन sp होगी, है ना. ऐसे ही अगर इलेक्ट्रॉन पेयर 6 होते हैं, अगर इलेक्ट्रॉन पेयर मान लो 7 हो जाते हैं तो क्या बन जाएगा sp3d3. अब sp3d3 में क्या क्या होगा? s 3p. Now we have a 3d, and these 3d are different, which were not used earlier. dxy, dxz, dxz. So now total we have 7 atomic orbitals. What is the geometry according to Sepper model is bent pentagonal bipyramidal. So you can draw the geometry. When you mix these all, you get this here. Pentagonal 1, 2, 3, 4, 5 in one plane. All are sp3d3. Again having the same shape. And one is above and one is below. In this case, we have example IF7. Now, in this case, you can calculate just like chapter model, like iodine have a valence electron 7 plus monovalent 7 by 2 7. 7 means sp3d3. Yes, it has a 7 atomic orbital. This is 7. Now, outer electronic configuration of iodine. अब आपको आयोडीन का एटॉमिक नंबर नहीं भी पता, लेकिन उसकी थोड़ी पोजीशन पता है टेबल में. यू कैन राइट इट्स आउटर कॉन्फ़िगरेशन लाइक दिस इज द हैलोजन फैमिली. फ्लोरीन की आउटर होती है 2s2 2p5, इसकी 3s 4s 5s, तो इसकी आ जाएगी 5s2 5p5. आयोडीन इन ग्राउंड स्टेट, जस्ट ड्रॉ 5s and 5p and D. 4D I think. Two, 5. When you write its excited state, this electron, this 3 shift are there, and you get, this is the VBT theory, you know, 1, 2, 3, 4, 5, 6 and 7. Now you can compare, like here these are 7 atomic orbitals, here these 1s, 1, 2, 3, 3p, 1, 2, 3, 3d. Now you must memorize that in which that if the configuration, your hybridization is sp3d3, which d orbitals are involved. If your hybridization is sp3d, which d orbital is involved. That you must memorize. Okay. Now suppose I put here iodine. So just add 7 fluorine atoms like this. So it becomes your IF7. The geometry is pentagonal bipyramidal. Now next is the orbital structure of ethane and ethane. Before that we will discuss a little bit more about the first 3 hybridization, that is sp, sp2 and sp3. So see this with the detail. These are the atomic orbitals s, p, p and p. If the hybridization is sp3, then the hybridized orbital will be, because when the hybridization is sp3 means all these 4 they will be used up. And we get a 4 sp3 hybridized orbital, you can see here. If all are used up, there will be no p. That means no pi bond, because p orbital they form pi bond. If there is a p, then there will be a pi bond. If there is no p, there will be no pi bond. Okay. If the hybridization is sp2, it means your 1s and 2p orbitals are used up. These 3 only. And 1p that left unhybridized. Okay. So we get 3 hybridized orbitals, sp2, sp2, sp2 and 1p that is remain as unhybridized. So when there is 1p, it means that can form a pi bond, 1 pi bond. Same is for sp. If there is sp, we can use only 2 orbitals and 2 unhybridized p orbitals remain as such. It means if we have a carbon, its hybridization is sp3, it cannot form pi bond. If it is sp2, it can form 1 pi bond, 1 double bond, either this side or that side. If it is sp2, it can form 2 double bond or 1 triple bond. We know that triple bond में क्या होता है, एक सिग्मा बॉन्ड और 2 पाई बॉन्ड. अगर हम देख लेंगे कार्बन ने अगर सपोज डबल बॉन्ड बना रखा है एक डबल बॉन्ड, इसका मतलब उसके पास p है. अगर उसके पास p है तो उसकी हाइब्रिडाइजेशन sp2 होगी. अगर कार्बन ने ट्रिपल बॉन्ड बना रखा है, इसका मतलब उसके पास 2p है. अगर उसके पास 2p होगी तो उसकी हाइब्रिडाइजेशन sp होगी. अगर उसने चारों बॉन्ड सिंगल बना रखे हैं, इसका मतलब उसके पास p नहीं है. p नहीं है तो उसकी हाइब्रिडाइजेशन sp3 होगी. लेट्स सी दिस एग्जांपल. So from here you can understand easily. तो आपको पूछा क्या जाएगा, ऑर्गेनिक कंपाउंड दे दिया, इसमें 6 कार्बन हैं, राइट दी हाइब्रिडाइजेशन ऑफ ईच कार्बन एटम. ठीक है, तो कैसे करेंगे आप देखो. इस कार्बन के चारों बॉन्ड सिंगल है, इसका मतलब इसने पाई बॉन्ड डबल बॉन्ड नहीं बनाया. इस मीन्स इसके पास p नहीं है तो इसकी हाइब्रिडाइजेशन हो जाएगी sp3. इस कार्बन का देखो, इसने एक डबल बॉन्ड बना रखा है, दिस इट मीन्स इसके पास एक p है. अगर एक p है तो इसकी हाइब्रिडाइजेशन हो जाएगी sp2. ये कुछ इसके साथ भी है, इसका भी एक डबल बॉन्ड है इस साइड, तो ये हो जाएगी sp2. इसके फिर चारों के चारों सिंगल है तो ये sp3. अब देखो इस कार्बन ने क्या किया है, ट्रिपल बॉन्ड बना रखा है. और ट्रिपल बॉन्ड में कितने पाई होते हैं, 2 पाई बॉन्ड. 2 पाई बॉन्ड का मतलब 2p. अगर 2p है तो इसकी हाइब्रिडाइजेशन क्या होगी भाई, sp. इसने भी ट्रिपल बॉन्ड बना रखा है तो ये भी हो गया sp. तो ऐसे हम हाइब्रिडाइजेशन जो है वो फाइंड करते हैं. और एग्जांपल देख लें. तो आपको एग्जांपल देगी CH3 CH डबल बॉन्ड CH CH. इसी में आपको सिग्मा और पाई बॉन्ड फाइंड करने के लिए भी कह सकता है, वो पहले हम कर चुके हैं. उसमें भी ऐसा ही था कि पहले हमने स्ट्रक्चर को क्या करना है, ओपन करना है. ओके, CH COOH. तो यहाँ से सिग्मा पाई बॉन्ड भी काउंट कर सकते हो आप. अगर सिग्मा पाई बॉन्ड काउंट करने के लिए बोला है तो सिग्मा पाई बॉन्ड लिखना है तो कितने सिग्मा होंगे कितने पाई होंगे वो भी लिख सकते हैं. सिग्मा पाई, सिग्मा है 1 2 3 4 5 6 7 8 9 10 11. पाई है एक यहाँ पे पाई और एक यहाँ पे पाई. हाइब्रिडाइजेशन हर कार्बन की, इसकी sp3 sp2 sp2, ये भी sp2. एक मेथड और भी है हाइब्रिडाइजेशन का. जिस एटम की हाइब्रिडाइजेशन लिखनी है उसको कितने एटम से डायरेक्टली अटैच है. अगर 3 से अटैच है तो sp3, 2 से अटैच है तो sp2, सॉरी sp. अगर 3 से अटैच है तो sp2, अगर 4 से अटैच है तो sp3. जैसे देखिए ये कार्बन जो है कितनों से अटैच है, 1 2 3 4, तो sp3. अब अगर ये कार्बन देखो ये कार्बन कितने से अटैच है, दिस डायरेक्टली 1 2 and 3, तो हाइब्रिडाइजेशन sp2. ऐसे भी कर सकते हो. सो दिस इज अबाउट द हाइब्रिडाइजेशन, टू फाइंड द हाइब्रिडाइजेशन ऑफ कार्बन एटम. नेक्स्ट कम टू द स्ट्रक्चर ऑफ ethene and ethine. सो ईथेन भी देखेंगे. ईथेन का फार्मूला हो गया CH3 सिंगल बॉन्ड CH3. तो 2 कार्बन है, फर्स्ट कार्बन सेकेंड कार्बन. कार्बन का मैं सीधा क्या लिख रहा हूं, एक्साइटेड स्टेट. एक्साइटेड स्टेट में ये वैलेंस बॉन्ड थ्योरी के हिसाब से बॉन्डिंग कैसे होगी वो बता रहे हैं पहले. ये इसका 2s, ये इसका 2p. इस कार्बन का 2s, इस कार्बन का 2p. इसमें होते हैं 4 इलेक्ट्रॉन, 1 2 3 एंड 4, 1 2 3 एंड 4। हाइड्रोजन है इसके पास 3 ना, तो 3 हाइड्रोजन यहाँ बनाएंगे, 1s 1s 1s, हाइड्रोजन हाइड्रोजन हाइड्रोजन। इसके पास भी 3, 1 2 and 3, so this is also 1s 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 3 हाइड्रोजन। इसको उल्टा करके लिख देते हैं। तो बॉन्ड कैसे बनेंगे पहले हम देखें। ये बॉन्ड, ये चारों इन्वॉल्व होंगे तो इस कार्बन की हाइब्रिडाइजेशन sp3 होगी और इस कार्बन की हाइब्रिडाइजेशन भी sp3 होगी। एलिस बॉन्ड की इसी हिसाब से देखते हैं तो बॉन्ड ऐसे बनेगा। इनमें बॉन्ड बन गया सिग्मा, कार्बन कार्बन, कार्बन हाइड्रोजन सिग्मा, ये सिग्मा, ये सिग्मा, ठीक है, ऐसे करके तो ऐसे बन गया कि ये कार्बन कार्बन। सेवन सिग्मा बॉन्ड्स। अब अगर मॉलिक्यूलर ऑर्बिटल पिक्चर बनानी है इसकी, तो इसकी हाइब्रिडाइजेशन है sp3 और इसकी भी sp3, तो इसके पास टेट्राहेड्रल ज्योमेट्री है। जैसे ये बन जाएगी, जैसे एक टेट्राहेड्रल, 2 टेट्राहेड्रल। तो स्ट्रक्चर कैसे होगी, ये कार्बन है फर्स्ट वाला, इसके हाइब्रिडाइज्ड ऑर्बिटल टेट्राहेड्रल शेप में sp3 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 sp3। दूसरा कार्बन है उसका sp3, ठीक है, इसके भी ऐसे ही sp3 sp3 sp3, तो दिस इज आल्सो फॉर्मिंग अ टेट्राहेड्रल। नाउ हाइड्रोजन attached here, okay, this is the s orbital of hydrogen, s orbital of hydrogen, s orbital of hydrogen, s orbital of hydrogen, like this. So this bond is formed between carbon and carbon. Here you can see. So this overlapping is called sp3 sp3 overlapping. And all the other 6 bonds, like this bond, these are formed by the overlapping of sp3s. So this is the orbital picture of ethane. Now we will discuss ethene. In ethene there is a double bond. And both the carbons are sp2 hybridized. So this is a ethene. Now see this carbon, ground state, sorry, right into excited state directly. 2s 2p. This carbon excited state, 2s 2p. दो हाइड्रोजन इसके पास है और 2 इसके पास है। So one carbon carbon bond, सिग्मा, इसके साथ सिग्मा, इसके साथ सिग्मा, इसके साथ सिग्मा। Okay, so you see that carbon uses its 1s and 2p, that is sp2. Here also 1s and 2p is sp2. This is unhybridized p orbital. They overlap sidewise to form a pi bond. Let's see first carbon. Its hybridization is sp2. sp2 का मतलब होता है it's triangle planar. sp2 sp2 sp2. It's trigonal planar. Second carbon उसका भी sp2 sp2 sp2. This is also triangle planar. So here we get hydrogen दो इस कार्बन के साथ, दो इस कार्बन के साथ. Now this carbon has one p orbital perpendicular to it, above and below the plane. This is unhybridized p orbital, this one. So they overlap sidewise to form a pi bond. So this is the orbital picture of Hc2H4. Last is of ethane. In ethane there is carbon-carbon triple bond. You can see here like this. If you see this carbon in its excited state, it will be 2s1 and 2p3. Second carbon in excited state, same 2s and 2p. One hydrogen is for this, one hydrogen is for this. Okay. So first bond formed between the two carbon, sigma, sigma, sigma. So this carbon uses its 1s and 1p. So its hybridization is sp. This carbon also uses its carbon 1s and 1p, so it's sp. So now we have two unhybridized p orbital. You can see here. Unhybridized p orbital. They will form two bonds, sidewise overlapping. 2 pi bond. So when the hybridization is sp, then the geometry will be linear. Here we get hydrogen. This is second carbon, it's also linear, and here we get hydrogen. Where are p orbitals? So here is a p orbital 1, p orbital 2. Here is also p orbital 1, p orbital 2. So they form a sidewise overlap. This overlapping with this overlapping with this. It's overlapping with this, it's overlapping with this to form 2 pi bond. So this is the orbital picture of ethene. So this is all about the hybridization. Then some methods to find the hybridization. You can use direct method. First simple method is number of covalent bond plus lone pair. If the sum of these become equal to 2, hybridization is sp. If it is 3, hybridization is sp2. If it is 4, hybridization is sp3. This is for only 3. For example, we have a methane. So there are how many covalent bond? 4, lone pair 0. So there is 4, so hybridization sp3. We have ammonia. So now number of covalent bond 3, नंबर ऑफ लोन पेयर 1 4 अगेन sp3 नाइट्रोजन की हाइब्रिडाइजेशन हो जाएगी sp3 टेक वाटर so number of covalent bond 2 number of lone pair 2 4 again the hybridization of oxygen is sp3 this is a basic method to find hybridization. Second method is to find electron pair. That is number of valence electron plus monovalent atoms attached. You can apply to this also. Number 2. If the electron pair comes out to be 2, that will be sp3, sp2, 4, sp3, 5, sp3d, 6, sp3d2 and 7 sp3d3. Like in this case you can apply this formula also. How many valence electrons are there in carbon? 4. How many monovalent atoms are attached? 4 divided by 2 4. Conjugation, the hybridization is sp3. Ammonia. How many valence electrons are there? 5. Monovalent atom attached are 2, again 4, then it's sp3. Oxygen, how many valence electrons are there in oxygen? 6 plus monovalent 2 divided by 4, again sp3. Like in SF6, what is the hybridization of sulfur? 6 valence electron plus monovalent 6 divided by 2, 6, it means sp3d2. Okay, CO3 2 negative. What is the hybridization of carbon? Carbon valence electron 4. Oxygen is divalent. Divalent के लिए 0. Monovalent के लिए 1. अगर divalent हो उसके लिए 0. Keep in mind. Plus 2 is negative. Divided by 2 3. It means carbon की hybridization क्या हो जाएगी? sp2. Okay, so this is easy method, just like the separate model. You can find the electron pair and write the hybridization. For example, sulfate ion is there. What is the hybridization of sulfur? Valence electron 6. Oxygen is divalent, plus 2 divided by 2 4. So sulfur has sp3 hybridized. What is SO2? Sulfur has 6 plus oxygen 0 divided by 2 3 means sp2. What is the hybridization of sulfur in SO3? Again 6 plus 0 by 2 3, it's again sp2. What is the hybridization of phosphorus in phosphate ion? Phosphorus has 5 valence electron plus oxygen is divalent 3 charge 4, it's sp3. You can find the configuration, hybridization of all the compounds by this method. But sometimes there is a problem. Like if the molecule is an odd electron system, like suppose we have a nitrate ion. What is the hybridization of nitrogen? You can find easily. 0 plus 1 by 2, 3, it is sp2. If we have a NO2, what is the hybridization of nitrogen? You can write it, valence electron 5 plus 0 by 2, it is 2.5. Then what to do? Then count the total valence electrons. If valence electron is 0 to 8, divide by 2. If valence electrons 9 to 56, then divide by 8. जो भी क्वेश्चन आएगा, that will give you hybridization. Hybridized orbital भी खुला जाएगा. अगर रिमाइंडर बचता है तो क्वोशिएंट प्लस रिमाइंडर. If remainder is there, then quotient plus remainder give you HO, hybridized orbital. Okay, let's see some example. Like NO2. The total number of valence electron, नाइट्रोजन के 5, ऑक्सीजन के 6, 2 ऑक्सीजन, 70, odd. So this is in between 0 to 9 to 56. So divide it by 8. 17 divided by 8. 8 to the 61. 1 remainder. So it means 2 plus 1. This and this you have to add 3. It means the hybridization is sp2. You can apply it to other molecules also, like so PCl5 is there. So total number of valence electron: phosphorus 5, chlorine 7, 7 into 5, 35 plus 5, 40. Come in this range. So 40 divided by 8, 5. So this is 5 that will hybridize orbital. It means the hybridization of phosphorus is sp3d. If suppose the sum of the electron, like here is 17, if it comes out to be 19, then divide it by 8 first. 8 to the 16. Now remainder is 3. 3 is in between and is more than 2. So further divide it by 2. Now this and this, we have to add these to get 4. The hybridization will be sp3. So these are the few methods which are applicable to all the molecules or ions to find out their hybridization. So that ends the hybridization topic.